Good morning, grade 12 learners. I'm Roland Siba, and we are proceeding with our maths class, which we are going to be proceeding with trigonometry. Before we start, a little bit of some information of who we are. We are dealing with the Smart Caps, which is sponsored by VT Africa Holdings and the Department of Education, as well as other sponsors. So I would want to welcome you back to our maths class, which will be for about 45 minutes, running on the concept of trigonometry. Today we'll be looking more into the part of the cosine rule. So along with that, you'll be required to have some assessment, which you can easily access on our site, which is you type hellosmart.com. So you simply go on your device, whether it's a smartphone, a laptop, or any device that is able to go on internet. And then if you have a bit of data, you connect to www.hellosmart.com. And then you're going to put to sign up as a guest, which is just a click away. And then you put the ID, which is reflecting on the screen, 598751. So you simply type in 598751. That will be the ID that will access the kind of assessments we'll be doing today. And you can put your name on the tab that will be open for you. So within 2 minutes, you'll be able to have logged in so that you can access our online assessments. Okay, so show us how smart you are. Okay, later on I shall flash this number again to remind you of if you have missed a figure or two. But let's jump right into our topic of trigonometry. Remember, we started to look into trigonometry 2D and 3D, which has to do with the sine rule, the cosine rule, and the area rule. These rules work much more if you have a triangle that is not right angled. So if you have a triangle that happens not to be right angled triangle, then you use your sine rule, your cosine rule, or area rule, depending on what you are looking for. And if, of course, the triangle is right angled triangle, you can use your sine function, which is, for example, sine of an angle will be equal to opposite over the hypotenuse, your cos adjacent over hypotenuse, and your tan opposite of adjacent. You can also use the Pythagoras if you are looking for lengths in a right-angled triangle. But when it comes to a non-right-angled triangle, then you have to resort to the sine rule, to the cosine rule, and to the area rule. Okay, so yesterday I left it where I gave a little work for you to check with the sine rule on number 8, which is on the screen. You will remember that part of our discussion was to mention that in this case, you might not have to look for BC because it's already provided. We already have BC on the diagram, which is 18. So we don't have to find BC as part of the question. So I'm sure that you looked at the different ways of getting this until you employed your sine rule. For example, one of the question is looking for angle B. So angle B. And part of the working would actually be, since you are looking for an angle which is a big letter, we will discuss that. You can simply look for the opposite side. But there's a relationship between the opposite side and that angle. And then you look for any other pair of opposite angle and side that is given. So in this case, your B, which in this case you are going to start by writing sine B. So by convention, your sine S should be small letter, but here and there it wouldn't matter. And so sine B over small b is equal to sine A over small a. So you can see the inversion we have used here. In this case, we are aware that we are looking for an angle, so we decided to start by putting the angles on top, which is your sine B over B equals to sine A over A. We could have still maintained the format of starting with the small letters on top. That will still work as long as you'll be able to cross multiply properly and make your question the subject of formula. But it's easier when B, which is what we are looking for, is already on the numerator. So part of your working was supposed to go something like sine B, if I might make B the subject here, it will still be sine B equals to B times sine A. So I've just cross multiplied the B here. And in doing that, in cross multiplying it, it becomes B sine A over A. You still have your denominator. So it's a matter of substituting this, and you get your sine B. So B small is given on the diagram, which we can annotate here. It's B, and this is small a. So small b is 6 times sine A, which is sine 105. Okay. This is all over A small, which is 18. You might have to be careful to check that your units are corresponding. Centimeter, centimeter. In certain situations, your examiner might mix units. You might have, for example, centimeters and meters here, and you will work with the wrong scale of numbers, because your answer will be wrong in the sense of the degree of accuracy, as well as if there's an angle, like in this case, you actually get a completely different answer to the one that is expected, because you are working with the wrong units. Okay, so I'm sure you worked something along these lines, and you got your B. To get your B, you'd need to say B is equals to arcsine of this, whatever answer you get here. So 6 times sine 105 degrees over 18. Okay. So by doing that, you will get your final answer of what B is using your calculator. Now that you have big B, from there, it's two angles that you have. You have the A, which is 105, and you have the B, which is what you've just worked out. It will be so easy to find your C, because it's the third angle in a triangle. So the sum of angle in a triangle add up to 180. So you subtract the other two to get C, which should fulfill the other part of the question. So let's see what those solution would give you. Your answer here would be B. It will be B, which means if you did it correctly, you were supposed to get this as your answer, meaning that our B is 19 degrees and our C is 56 degrees. So probably because there's BC still in the answer, which we said you could ignore because it's 18, it's given. It could mean that the question was trying to get a different side, most likely AB. So you could find that as well using the same rule. Okay. Let's see what comes after. So I'm going to give you this as something that you can work on later as you check this, and we won't have time to draw much on it. You are using the very same principle to find AB. But let's talk briefly about it. This triangle is a compound triangle because it is combining two or more triangles. There's usually some riddle where you're asked how many triangles are in this diagram. So it could pass for something like that. So maybe you will see 3 triangles or 2 or so. It's not one triangle. So having that in mind, you are looking for AB, which is this. Now, you see that there's a conflict of naming this particular line. So on one side, you could call this line from this D, you could call it small d. And then if you look at the bigger picture, the bigger triangle, you could also name this same side from your C. So from C's perspective, you would have small c. So as I mentioned, the names don't really matter much. It's all about you remembering what you named the side or the angle you were looking for. So it's not in the name, but in what you can achieve. Okay, so you could choose any one of these names arbitrarily, or any other letter. You could say, since there is a conflict of D and C, I would just call this side, for example, small p. Okay, so that will still be fine if you decide on that. So in fact, let me do that. I'll just call this small p. Okay, you can also call it small t, any other letter. So in this case, which means we are looking for AB, we have to look for the best triangle with enough information to give us AB. So if you check the smaller triangle, we don't have information at D, which we need because we need something that is opposite to the side we're looking for. So the best choice would be to look into this part where there is the bigger triangle, where they C. So from C's perspective, this side would be related to C. So maybe you end up with something like like your P over sine C, which you could use small c as well in this case, is equal to, then you look for any other side and angle that are already given. So I can see here that we do have our angle A, and we can just call this side small a. Of course, there is a potential of small a as well here, but in terms of BC, we can call it small a or even BC. So BC, if I may call that, over sine 59 degrees. Okay, which means somewhere along the line, you are going to end up with your P, which you are looking for, which is actually AB, will be given by your BC, which is 26. This could be centimeters or millimeters. We are not given the units, times. Then you go to sine C, which will be sine C is 36 all over sine 59. Okay. So this should give you the desired side AB. So since that we looked into this, you should see that your answer is B, as given here. So your answer will be B. So try and look at it and find out. If you are on YouTube, you could pause and actually take it through to the stage where you get B equals to 17.83 units. Okay, let's then start on the cosine rule. All right, so the cosine rule is another method we can use to solve triangles. The same way we use this sine rule to solve triangles, which we needed angles or sides. But we don't just use these rules randomly. There are instances that you must look for in order to be able to use these tools. So how do we use the sine rule? Sine rule, not cosine rule. So sine rule, if I can write it in short like that. Sine rule is, we said you can use it if you have a side which is side, angle, triangle. So a triangle where you are given the side and another side following, and then an angle. It also works where you have just a side followed by an angle, followed by an angle. And remember, this is from any direction, as long as you following consecutively, that you have a side given, then an angle, then an angle. So there you have to use your sine rule. But where do we use the cosine rule? So the cosine rule is used as we are reading here. So it's used when we know that we have two sides that are given, and then the size of the angle between them. Okay, so in this case, you can use your cosine rule. Okay, so this part would be two sides and an angle between them, like that. So what does that mean? In terms of our understanding of a triangle, this would simply mean we can use this for a triangle that has side, angle, side. Okay, so we must know the length of a side followed by an angle followed by a side, which means this angle will be included angle. We did mention this when we are dealing with the area rule, which also desire that you use this side, angle, side. So the very same thing you are using as well for the cosine rule. You just make sure that your triangle, you are given a side, followed by an angle, followed by a side. Then, if that's the case, you have three formats of using the cosine rule. If you are looking for examples, small a, remember it can be different letters, then you make sure that you have something that looks partly like your trigonometry, if you check, rather your Pythagoras. So you see this part would be a squared equals to b squared plus c squared. That looks like Pythagoras, isn't it? But being the cosine rule, you then extend it by this part, minus 2bc. So you're taking the b and the c from these two times sine a. A will be that first one. So what you start with is what you end with in this form. So that's a way of making you to be able to remember this formula, but it's actually provided in your formula sheet at the final exam. So if I was looking for small a, I would use that formula. Okay, so that will be for small a. In the same vein, if I am to look for small b, then I can use this. The good thing is that b is already subject of formula in the form of b squared, so it will be easy to get your small b. You just have to put a square root, just like Pythagoras calculations. If obviously you are also looking for your small c, then you use this formula the same way. So this formula would work for any of these three sides, provided you are given side, angle, side. So you are looking now for the side that is opposite to this angle that is included. Okay, in that case, let's then dive into some practice and questions. So this is an example. The example comes in a compound triangle already, which we just discussed, mean that we have more than one triangle. So in this case, we have two triangles. There is the smaller one, and then we have the bigger bottom part of the triangle. And what we can do in finding BD, we have to check which one applies between what we know so far, our sine rule or cosine rule. But in this case, we'll be using more of the cosine rule, naturally, as we are practicing to put it in practice. So BD would be this part, this whole length, BD. And I have to look around and check which triangle I must use, the triangle that has more information, whether it's big or small, I will choose that to solve the question. So it's a very good principle in life that where you have more answers, that means that could be the correct decision. Okay, so I see that the bigger triangle seems to have a bit of more information. Look, we have this side is given, an angle is given, a side is given. So we have three informations in that bigger triangle compared to just about two informations in the smaller triangle. So I would go with the bigger triangle. And now let's check if it can satisfy the cosine condition, the cosine rule condition, which we said that we must have a side angle side. Yes, indeed, we have a side followed by an angle followed by a side. Okay, so we can use the cosine rule since that we are looking for this side here. So to do that, I'm going to call this side, which we said can have two names, but in this case, since the bigger triangle has one, this is small c. Okay, so I can now say I'm looking for small c here, which small c is actually my BD. So in doing that, I can say small c squared is equals to the other two sides that are given, which is your, let's call this one your small d, and this one your small b. So that means you have to say small b squared plus small d squared minus 2bd cos c. You remember that formula? So I'm going to substitute this to become 27 squared, which is your small b squared, and then 23 squared minus 2 times 27 times 23, and then we have that we have, so this is still our d, times cos 62. So I just did a quick rough work here so that we find out how we can get our BD from this, but this is worked out for you on this slide. So that's exactly what we have just done. We used this formula and we get to substitute. There's a point where you get your c squared, and then you simply square root it to find your BD. Okay. The other question was, what is AD? What is AD? So where is AD? So AD is simply this part. So AD is this. Okay. So as I mentioned yesterday, while you are solving problems, especially with any diagram, you must always populate your diagram as you go. So whatever information you get, you must come back and put it on the diagram. That information will help you to get to the next step. So in this case, what do we get for our first question? We got that BD is 26 meters. So if we can check that page to compare these two, you see that we are going to now put that value where BD is, and we can say that BD, which was small c in our case, is actually 26 meters. That will help us to realize that the other triangle that we had said was a bit bereft of information is now having more information. So the small triangle, if you check now, it is more information in the form of side here, angle here, side here. So which means we can now use it to find AD, which happens to be only on that small triangle. So to do that, you can actually use the formula, which is the cosine rule, to find that small b. So in this case, that's your small b here. And you simply say small b equals a squared plus d squared minus 2ad times cos b. Then it's a matter of substituting these two sides and the angle on your right-hand side. So eventually you get your AD as 15 meters. Finally, you are also asked to find the angle A. So to find your angle A, you also notice which of the SAS is going to include that angle, and then it should also be one of your steps to make cos A the subject of formula, because you are looking for an angle this time. So as you can see, is worked out here. Our diagram is quite having a lot here, but you should be able to still see that while we are looking for angle A, we are looking for this angle here. And we do have a lot of information in both triangles, but A happens to be in the small triangle only. So we check if we have enough information in that small triangle. Remember, we found AD just now. So remember to populate it on your diagram. So here I'm putting it 15 meters. Okay. So in this small triangle, we now have a side, an angle, a side, and another side. So in this case, we are looking for an angle A. So if you are looking for big A, we use the formula with small a, because that will give us big A at the end. Remember that relationship? Okay. So if you use that, you will see that our triangle is already a side angle side, because it has a lot of information to include a there. So a squared equals to b squared plus d squared minus 2bd cos a will give us, where there's a squared, we have 26 squared, which we just found that time. And then equals to b squared will be 15 squared. And then d squared will be 15 squared. And then you just substitute your b and d in that formula. The only thing you don't have at that point is your cos a. You don't have a there. So you then you transpose all this to the other side until you remain with cos a. You will see that it is a negative number. And being a negative number, your calculator is intelligent enough to assist you here to find the angle. If you were the previous grades, they would have to consult with tables in books and so forth and get the function to be corrected to give you an angle. So if you know your trig from grade 11, you remember that cos is actually negative in the second quadrant and in the third quadrant. So because this angle is bigger, which you would see on the calculator, it's 91, it's in the second quadrant, hence cos was negative. Okay, so I hope that you're starting to get some indications of how do you solve a question where cosine rule is required. The first thing is to recognize that there is a side angle side situation. So the angle must be included between two given sides. Okay. So there is your opportunity. I'm going to actually allow you to just look at this briefly. And then on the next question, you are going to try it on your device. So this question is looking to solve what is the minimum information needed to use the cosine rule. So it's sort of a walk in the park for you now to realize that is it the sizes of all three angles? Maybe the lengths of two sides and the angle between them. The sizes of two sides and their respective angle. Oh, two sides respective, all right. The sizes of one side and its respective angle, or one side and one angle, all right. So you are deciding there, you're simply looking for what sounds like side, angle, side. Okay. The first situation is side, side, side. So you cannot use the cosine rule as such to solve such a triangle. Though with experience, you realize that you could use it in a form where you already have the three sides. Like in the last example, we are looking for an angle. So you could use the cosine rule in terms of the angle to find these angles. Fine. The most appropriate answer here, if I was to pick only one answer, because we are looking for the minimum information, could be number 2, because number 2 seems to have side, angle, side situation. Okay. Because we are looking for two sides and an angle between. Number 3, on the other hand, is it's a side, and then we also have angle in between angle. So it's sort of a mixed bag. This one, it's not minimum. And then the last option would give you side and angle. That's not enough information. So the best answer here I would opt for would be B, which would give you your cosine rule without much trouble. Okay, now that you're seeing the direction of things, let's involve you a little bit more into what can become very interesting as you discover the method at hand that you can employ to solve these questions. So here is an opportunity for you to start delving into this particular question. I'm going to connect you within the minute so that those who are using devices can actually work on their devices and we see what are their inputs. Those who are using pen and paper, you can see the screen is already showing for you to start looking at the question. Okay, so you see that I will read the question while I will connect those that are on gadgets in a few minutes. Before I read that question, I'm going to remind those who must connect that you are to go to the website, which you type www.hellosmart.com, and then you sign up as a guest using the ID number 598751. Then you add your name there, and voila, you are connected. Okay. All right, so you could start demystifying this question to see what is the story all about while you wait for a gadget to connect. So those who have, yes, so you should be able to be on the, yes, you should be actually be on the platform now on your device to answer this question. This question, just to decipher it a bit, it's looking for CE, or rather CE is actually given, which is what? Let's just put those information and then you guys will solve it. C is given as 21, always read the whole question. C, the angle is 37. And you also have to determine DE and angle D and E. So you're looking for this and this. You are also looking for DE, that. So in terms of calling this, you could just call this small d, this one small c, and this one small e. So what do you notice about the whole situation? What kind of triangle is this and all that? So think along the lines like that. Think along those lines. We have generally 3 triangles. There's a scalene triangle where all the sides are not equal to each other. And then there's an isosceles where 2 sides are equal to each other. And we also have what we call the equilateral triangle, where all 3 sides are equal to each other. So there's a relationship between all those things with the angles that are embedded in that triangle. Okay. So while you have, I trust you have copied this question, it's also a good practice, grade 12, to kind of copy the diagram on a paper if you are using a paper there, and you have it as a practical picture before you so that you can find out how to solve it. It will be good in this case so that you put more information on it. So along with that, as our time is up, I want you to look into this as part of your homework as well. You have another triangle here, which is a compound triangle. So it's already having some information given. So up to you, you can call this triangle, for example, A, B, C, D, or PQRS, or XYZ, A, or whatever. So try to give it some name, and then you are looking for X, Y, and Z, and you should be able to start seeing the kind of triangles we have, side, angle, side, and all that. So do this as an exercise you can look at as a homework. So on that note, thank you very much. We had a wonderful lesson on the cosine rule, which we use mostly for situations where the triangle is not right angled and it is side angle side where the angle is included. With that, thank you very much.